Did you see any of the Star Wars movies?
Yeah, of course I did.
I feel like it's easy to forget that it's called that.
Yeah, it's the toothy desert monster that Boba Fett falls into.
The Jabba the Hutt scenes. And then not just what's his butt falls into.
What's his butt?
Like falls into the pit and then gets out. Mark Hamill. Luke Skywalker. This is going to be a good pod today, everyone.
Welcome to Walkabout the Galaxy, the unpredictable astronomy podcast where the science is universal, the opinions are personal, and the intro is ad-libbed.
Congratulations.
We are Strange, Charm, and Down, the Astrocorks, also known as Josh Colwell.
Addie Dove.
And Audrey Martin.
Coming to you from the Walkabout studio at the University of Central Florida, top cork Jim Cooney is AWOL today. Subscribe to us on all platforms, including Facebook, Instagram, and Threads, where we promise not to clog your feed. And also on YouTube, where we do post things, but we will not clog your feed there either. In the meantime, you can contact us anytime at wtg@ucf.edu through the ancient technology of email with questions, suggestions, and compliments. Our stumper today is Sci-Fi Alienal.
Okay. Alienal sounds a little too much like urinal or something. I don't know. I didn't like it.
Audrey, you were just telling us about how you went to see Dune.
I did.
Part 2.
Yep.
Out in theaters now. Have you read those books, by the way?
No.
You're much too young.
No, she's not
a reader.
I'm not a reader.
Oh, you're not a novel reader or sci-fi reader?
I'm not. The names are too intense, and I get lost.
Isn't Dune the one where there's like lots of appendices because it's like explanations of the words and stuff like that in the back?
I don't think so.
And the lore.
The story I told when I saw the David Lynch Dune in the theaters.
Maybe I am thinking of that.
Where they passed out a glossary of
I
was thinking of somebody talking about. I thought it was Dune, where like they had that part of the book was something where because you had to like reference it, but maybe it was a different book.
Maybe.
I don't think so. So I have read those books. I read the first 3 twice.
Oh wow!
But the last time was before Audrey was born.
I wish more movies came. I wish more movies came with like a playbill type thing where it like gave you some information. Nice. You're sitting there in the beginning, they play all that stupid crap you don't care about.
30 minutes of advertising.
Yeah, that's why we don't ever show up because you buy your seats now, so you don't have to show up until the movie's starting.
Yeah.
Right. But anyway, if you had a little playbill or like a little, here's a background. Yeah. Maybe they could put like less crap in some of the movies.
Tree or something.
Yeah, because sometimes they had all this stupid exposition that you can figure out if you're an intelligent movie watcher.
Yeah.
I'll leave it there.
Well, in any event, our stumper is Dune adjacent.
Sweet.
The sandworms are a big part of the whole Dune story.
Are those the ones that are black and white striped?
No.
It's Beetlejuice.
Oh. Here's your stumper. Sandworm or sarlacc?
Oh.
Another desert.
Can I say neither?
Creature.
What's the contest? Am I being eaten by one of them?
Your choice.
I feel like what's the odds of surviving a sandworm?
Probably worse than the sarlacc.
Yeah, the sarlacc we learned recently from like the Boba Fett stuff. You can just like live in there and survive for a while. So
also, they seem to be kind of stationary.
Yeah, that's true.
Right?
So I'm going to go sarlacc.
The sarlacc is. Do you know what the sarlacc is?
I'm looking it up right now.
Audrey's Googling sarlacc. Did you see any of the Star Wars movies?
Yeah, of course I did.
I feel like it's easy to forget that it's called that.
Yeah, it's the toothy desert monster that Boba Fett falls into.
The Jabba the Hutt scenes. And then not just what's his butt falls into.
What's his butt?
Like falls into the pit and then gets out. Mark Hamill. Luke Skywalker. This is going to be a good pod today, everyone. Are we talking about space things? I'm going sarlacc, though. It seems much, stationary and survivable.
Yeah.
I think
they're both toothy.
They do move.
Toothy things that live under sand.
I think I have to go with the Dune worm because this isn't a spoiler because it's in the trailers, but you can ride them.
Yeah.
And that looks fun.
It's also in the book. Yeah.
What book? Just kidding.
I'm going to go with sarlacc too, just because the whole how that gigantic worm is actually moving through sand.
You don't like the physics?
I don't like the physics of it.
You know that would be a really fun little like problem to go through, right? Because granular materials freaking hard, right?
Yeah.
So
You
complicated.
have to displace a huge amount.
Yeah, and it's hard to displace a huge amount of sand. Like the weight of all the sand on top of the thing is a lot, and then you're trying to move through it. It's very difficult. They must have some sort of like cohesion reducer that they exert.
Astroquarks say Sarlacc 2, Sandworm 1.
That's right.
Yeah.
Okay.
Today we'll talk about a hidden volcano on Mars and a chance to see a nova with the unaided eye, and much more. But first, this episode of Walkabout the Galaxy is brought to you by the Mariner Valleys.
Oh,
Okay.
Embark on the adventure of a lifetime with a trek through Valles Marineris. The Mariner Valleys extend over 4,000 kilometers across the Martian Tharsis region with a depth several times that of Earth's Grand Canyon, offering unparalleled vistas. Start your journey in the labyrinth of the night with its famous steep canyons. If traveling by foot months later, you'll complete your Mars trek in the ancient eroded terrain of the Golden Plain, Chrysi Planitia. Get the authentic Red Planet experience in the Mariner Valleys. Valles Marineris. Visit and love us.
visit and love us.
Grand Canyon National Park.
I feel like it's a state.
You're both on the right track, but
Nevada.
category.
Virginia.
Oh, visit and love us. Oh, wrong category.
Well, the right, I don't know. It's Brazil.
Oh, okay.
It's
Interesting.
Obviously a place that wants you to visit. I love them.
Okay, I will.
That's complicated.
Yeah.
If I have to, I guess I will.
I don't think I ever knew that Valles Marineris meant
Mariner Valley.
Mariner Valleys. I always thought it meant Martian Valley.
Oh.
But it was discovered by Mariner when it flew by Mars and took pictures. So I think it's a smaller number.
Okay.
Like 4 maybe or something like that.
Cool. Okay.
So yeah, up to I think 7 kilometers deep, but it's so wide. that,
Yeah.
But it does have some steep-walled segments with various stretches of it.
Totally. Yeah.
But gigantic system.
Yeah.
There's some interesting space news.
Space Starship,
There was the Starship launch, Integrated Flight Test 3.
which went places and did things.
Ooh,
did.
could you be more specific?
I'm barely. I was watching it, but I was also in meetings, unfortunately, and so I feel like I missed some crucial bits, like what actually happened at the very end.
So this is the third integrated flight test of SpaceX's Super Heavy launch vehicle with their ginormous Starship on top of it.
And the last 2 times it blew up.
Yes. The first time it blew up pretty early before it was really in space.
Yeah.
The second one, the first stage successfully completed its burn. The Starship successfully separated. And then they both blew up at not too many minutes later.
Got it,
after
okay.
that. This time, they went a little bit further. The Starship the Super Heavy, the first stage, which has 33 big rocket engines at the base of it, successfully reignited some of those engines to do what they call I believe a boost back.
They had a couple of I'm not thinking of an appropriate phrase to use, but shots of the underside of the rocket, like when they were when it was on the pad, and I feel like maybe they haven't had those before. Maybe I just didn't notice, but so many freaking engines.
Yes.
Oh my god,
Oh.
it's so many engines. I was just like,
big are
that's a
they
lot of
all?
engines.
Yeah.
I mean, they're regular engines, but 33 of them.
They're much bigger than what.
Well,
They're like
they're the regular, yeah.
They're big. They're powerful rocket engines. They're not as powerful as the one that were on the Saturn V, but they're like a third as powerful as those. So 33 of them is a lot.
But it did blow up again?
So
Well,
it did a
the booster-
burn to fly back,
Yeah.
and then it's supposed to, as it's coming in,
Supposed to land like the other ones do.
Sort of do a gentle touchdown.
Okay.
And that
part didn't happen.
Didn't happen. And I don't actually know why. And then the top part
The top part
kept going
did basically
and did
what it's
some
supposed
sort
to
of
do.
inversion thing.
So
Because it does like the right angle, like.
It does a flip.
yeah, it's a sort of for whatever reason I associate that rocket with like old-timey sci-fi.
Because it looks like old-timey sci-fi B-movie rocket.
And so it was the planned trajectory was for it to splash down in the Indian Ocean.
Okay.
Basically a half an orbit after launch. So it started its reentry. We got some amazing live video from the rocket exterior.
There's a lot more live video this time, which was cool.
Really?
Yeah.
So you can see the plasma glowing around
so
the rocket.
Cool.
That was cool.
You see the rocket maneuvering. It's got ceramic tiles to help with the intense heat generated by friction with the atmosphere during reentry. So you could see that happening for several minutes, and that was very cool. And then they lost contact, and I kind of felt like it maybe wasn't surprising that they lost contact, but then once it slows down enough, they should have regained, and they didn't. So
something went wrong.
It had a failure before.
Comms during plasma stuff is hard because plasma stuff is charged particles, which messes up electromagnetic waves, which are comms.
Yeah. But then the vehicle had a catastrophic failure during that reentry phase.
Okay. But that was further than what
they did. It's much further. They did some tests. They did some testing on propellant transfer, which I don't fully know which aspect of it when that was happening. But that's super important. I don't know. I think we've talked about that on here for the 10 plus refuelings they're going to have to do to apparently get Starship to the moon, which I still don't understand why they need that many.
It's a giant rocket.
Yeah.
And
maybe
so
just have
but
like the Saturn V was a giant rocket, but the Saturn V had giant rocket and then slightly less giant rocket and then little tiny capsule.
Exactly.
Whereas Starship has giant rocket and then also giant rocket.
Right, exactly.
I decided it is why. Okay, great. Yeah.
So it was definitely they moved the ball down the field,
kicking the can,
and they have said they may do as many as 6 more test flights in 2024.
Oh my god!
I think
that's a lot.
I would divide that number by 2 or 3.
I would divide it by
in March. I think probably 3 more test flights seems feasible.
Oh, we should have a wager, a pool.
Yeah.
I think 4. I'm going to go.
More?
I usually don't go on the side of optimism for these things, but I think 4. In other space news, we got some transparency on the NASA budget this last week.
The 2 of you were just at the Lunar and Planetary Science Conference, which is a major scientific meeting about the moon and planets.
Yeah.
What you learned.
Yeah, so we were there. There were lots of really great talks, lots of good conversations. And so there's lots of things coming out about this. Just like most of the time when there's a big science conference, there's a bunch of articles in the news about some of the new findings and stuff like that because people wait to release papers or they release first results. A lot of times at these meetings, there were a few really cool sessions about results from Bennu and the samples from OSIRIS-REx. They looked at OSIRIS-REx samples.
Early peek at that kind of stuff.
Yeah. Audrey seemed more. They have compositions of minerals, it turns out. That's about all I took from that.
One of the cool things,
there's more sulfur than
and
there's not phyllosilicates or something.
No, I think there are.
There's not
but
something
the one
else.
result that I thought was really cool and just a nice good check in the box of remote sensing works is that they got one of the groups got just kind of a bulk sample and tested it against one of the spectrometers on OSIRIS-REx and was like, oh yeah, great. That's what it looks like.
Things.
It looks exactly the same.
Yay.
So that was
nice.
good. That's good to know. It's always good to be like, oh yeah, okay. These instruments work.
Right.
Yeah. And it's the sample from the thing that we confirm and all that stuff. Yeah.
Exactly.
There was lots of good moon sessions. Lots of talk about ongoing missions. There were special sessions for both IM and Astrobotic, and I missed both of them.
Well, one of the stories I saw recently, did they talk about this at LPSC, the Indian lunar lander? Chandrayaan 3. Yes.
Yeah, there was a cool talk, and it was actually in one of the moon sessions. So one of the sessions was updates and current new results, and most of it was from some orbital data, including the Korean Lunar Polar Observatory, KPLO, so Korean Polar Lunar Observatory. observatory. And it has several cool instruments. So it has one that's a polarimeter, so looking at like how light behaves when you're looking at different angles and scattering. And then they have an instrument that's built by folks in the US called Shadow Cam. And the goal of that one is to look in dark areas of the moon, in shadowed regions. And most of it is like, oh, we're looking in craters, permanently shadowed region craters, and it turns out they look like craters. So it hasn't been, apparently there haven't been very many really super exciting results. They're hoping to get a little bit more that'll tell them about like surface structure and things like that would be useful for understanding like if there's water there. But there was one that they talked about that was very like, it looked very like more like a Martian crater where there would have been water present or something. Like it was much more rounded. Like than you usually see, like the edges and the lobes of the crater were like much more rounded, like it was an impact into an aqueous thing. It was very different than like most other lunar craters.
And the ejecta, it was like petally instead of
it wasn't streaky? I don't think it was. I think there was still some streaky, or it's it's too old to be able to tell, but it was definitely like it was roundier than sharp.
Cool.
Which is kind of cool.
That's so
weird. Then the Chandrayaan-3, there's a talk about the Chandrayaan-3 lander, and they did have some cameras that they used to look at the plume effects when they were landing, which is exciting because both of the other recent U.S. missions haven't been able to do that data.
Right. So these plumes are the dust and stuff that is kicked up by the exhaust of the rocket engine blasting into the surface as you come down.
Yeah.
If you look on YouTube and if you look at videos from like the Apollo landings, you can see kicking up some dust, in fact, was spoken by Armstrong or Aldrin on Apollo 11, the descent to the moon. It's like, it's a problem. And we've talked about this for, especially like this giant Starship rocket.
Yeah.
It's giant rocket engines when it's landing on the moon.
So Phil's done a bunch of work on that, but he can't ever talk about it because it was under contract with SpaceX.
Yeah,
but their engines are much higher up.
What does that mean?
Their descent engines are much higher up on the really tall big rocket, so they might make less of a on the surface, which relates to what we're talking about. Yeah, so Chandrayaan-3 apparently, and I didn't know this, but so Chandrayaan-3 is a little lander. The little landers don't make huge messes, but they do kick up dirt, and usually you can see the like sort of footprint scour area around where they land. It's called like the blast zone or the scour zone because you scour the material off the surface. And we've looked at this for Apollo and Surveyor and the Chang'e landers and the Chandrayaan landers, but this time apparently, I didn't know until this guy was giving this talk, that they had one of their engines, instead of typically they're just like straight down underneath and sort of in the center, or a few along the edges, and from 800 meters on, only the diagonal engines were kept on. So they had engines that were firing sort of off to the side, so not straight down, but more off to the side to slow them down. And so those were the only ones that were kept on until touchdown on the surface. And then those were shut down after they landed. And so they have data, and it's not like they don't have a lot of frames because either they were moving faster or they just had a really low frame rate. But at 12 meters up, they don't see plume effects in the camera data. At 8.7 meters, they do, and at 4.6 meters, they do. So they don't see it until like 9 meters above the surface, which is like, usually it's like 30 meters or something that you start to see stuff. So like they're definitely mitigating the effects. It could just be that if they're shooting off to the sides like that, right, it's causing something, but not as much. Could be their their field of view is not quite right. So there's a bunch of questions I have about this. But it does seem like based on like Apollo and the previous Chandrayaan and Chang'e missions, the effects we're seeing were much lower and much less than in previous landings. And the other interesting thing was that they looked at data on like which bands they could see it in. It was either in like camera data or something else, and they could see it the most in the blue light. I think it was something with their solar panels. I was a little confused about that. But over the solar panel bands. Yeah, but I don't understand. Anyway, and so they used also that to see when the light was being blocked, and in the solar panel bands they only see it in the blue, or they see brightness increases in blue and decreases in red and green, so it's like scattering the light differently and brighter in the blue and then dimmer in the red and green, so it's like being blocked in the red and green from the dust, and that just has to do with like the wavelengths of light or the size of the light and how they scatter light, which is what a bunch of the instruments we're trying to design do. They use different wavelengths of light to look at scattering and particle size.
So
that's kind of cool. But I'm super curious to see like exactly what the geometry was of the engines and like see a full paper on this.
I mean, a little bit of it sounded like, surprising, findings from the Chandrayaan 3 lander. It kicked up less dust, and then it's like...
But that's what they were trying to do. And it had tiny engines.
Really pointing down.
Yeah, some of the...
Okay, so that doesn't really work with a giant rocket, because then your rocket's just going to crash.
Yeah, exactly.
Yeah.
So, It was cool.
Moving a little bit further out in the solar system.
Oh, wait, but I was going to talk about the budget really quickly. So just really quick. Not great. So there's all this stuff
Overall,
for science budgets that was cut with some agreements in Congress. And so they're holding to that. So the hard thing was, or the interesting thing was, right, is that they finally released the budgets for 2024, the appropriations for 2024, like this last week.
Right.
And the president's budget request for 2025 came out this week. And it like all happened right before LPSC. Like it was the day of NASA night at LPSC was the president budget request. So none of it's great. It's better than it was a decade ago, but it's worse than it was 3 years ago.
It's really bad if you care about Mars
sample return. But honestly,
which I don't really care that much about. So
it's not as bad for you.
It's not as bad for me.
Yeah. So like
selfish.
I know.
So the head of the Planetary Science Division was talking about stuff, and she was showing how it's like distributed across the different directorates, and like heliophysics actually does pretty well. BPS gets a little bit, biological and physical sciences gets a little bit of a bump, which is great because they have like no money. Planetary gets hit the hardest, and most of that is in Mars sample return.
Yeah.
And then Earth Sciences was sort of flat,
And
I think. And astrophysics was
I think it was
fun.
also
It was a little flat, or maybe a tiny bit less, but like planetary is where they really took the big hit, and it was mostly an MSR.
Yeah.
Which we knew. And there's
it
some
wasn't-
assessment of like, they're doing some assessments right now to see like, okay, we'll give you this much money. You can get a little bit more, but they're doing some assessments right now of like how much more they need, what can do, how realistic is it. So it's interesting.
Well, if you have to make a big cut, that kind of is the place to go because it's a very complicated mission architecture as we've talked about on previous episodes.
Yeah. And there's a lot of, there's a bunch of money still going to moon stuff, but that's in conjunction with a bunch of human stuff and a bunch, so it's like you have to programmatically balance. And Venus missions are both back on the table. So in the 2030s is the year of Venus.
Woohoo!
The 2030s is the year of Venus.
The decade of Venus, sorry. Yes. So that was exciting. And it was interesting because like sometimes those go really poorly. Those nights go really poorly. And generally, I actually think because of how upfront Lori Glaze was about everything and how she communicates it.
And beforehand, too.
And beforehand, too. It was much less negative than it could have been.
People just were being realistic and were appreciative.
Mostly. A lot of questions were like, hey, what's the deal with Starship?
Oh, yeah. We all knew kind of what was coming. We just didn't have the numbers for it. And so it wasn't a huge surprise. But really excited for Venus.
Well, before we do our trivia, I want to hear about the interesting discovery on Mars.
Yeah, so this was one of the findings out of LPSC. Apparently, there's another massive volcano on Mars that has been hidden to us for all time.
Hidden by Martians?
Hidden by Martians.
Suspicious.
No, probably not. I mean, maybe. Don't want to count it out. But probably not. So there are 4 pretty huge volcanoes on Mars. One of them is the largest.
Olympus Mons.
Olympus Mons. There you go. Nice. There's also 3 others.
Erasmus, Pavonis, and Arcia.
Show off.
Mons.
Nailed it.
I might be looking at it. So. Also, I've been playing Mars a lot lately. Terraforming Mars, the board game, a lot lately. It's an excellent board game.
Okay.
That sounds fun.
And there's an app so you can play with your friends.
Mars.
It's called Terraforming Mars. And there's an app.
Is it a free
board
app?
game you pick up at Target or something? Or
I wouldn't buy any board game at Target. I'd
Like
support
a
my
board
local
game?
small business.
Yeah,
but
Josh.
one could pick it up at Target. Yes.
Okay. Terraforming Mars.
Yeah. We've never told you about this before?
No.
Sounds really fun.
Okay, you're coming over tomorrow. It only takes like 3 hours, so it's fine.
Oh,
That's
one
not
of
too
those board
bad.
games. Okay.
Eric and I have gotten it down to like an hour and a half.
Oh, okay,
so.
sorry.
Okay.
Anywho.
New volcano. It's not on the map for terraforming Mars.
Well, not yet.
Not yet.
Okay, so our sponsor today, Valles Marineris, at the very end of this large canyon are these kind of like weird polygonal cracks that people have been looking at for like
Scratching their heads.
There are
those polygonal
compositional like tracers of glacial activity and potentially like current glacial activity, which is really cool. And so that's what these researchers were doing. They were looking at glaciers or like buried glaciers and that kind of thing. And through a combination of composition, so volcanic ash and things like that, as well as morphology, so how everything is shaped, they uncovered, metaphorically, this new volcano that is like 450 kilometers in diameter. So it's the same diameter, if not larger, than the other 3 massive ones that we know and love on Mars.
But it's like really eroded.
It's super eroded, so it's definitely older, but it also might be younger.
Nope.
So it started for the stratigraphy to work, it would have had to start before the other 3 massive ones. But compositionally, it looks like there's been recent activity.
Recent activity because of that volcano, or just like other stuff that's happened, like the glacier stuff?
I don't know.
Oh, okay.
I'm not sure.
And how recent means like 1 billion years ago instead of 2 billion years ago?
Yeah, I think so. This was in an abstract. It's not published yet, so I haven't read the full paper.
Yeah, I looked through the LPSC abstract, and it's got some crappy figures.
Awesome.
But it has some fine figures too. But yeah.
the space.com one has really good figures.
Has very pretty figures.
Yeah, the figures are really nice. But yeah, there's like lots of ash and stuff like that, and also the morphology of it. And so the reason why people care about this now is because this area is not near the poles of Mars, where you would expect a whole bunch of like ice and stuff like that. This is near the equator.
Right.
And so this means, number one, if there's like current glacial activity, maybe some water for when we send people there. Water is important for a lot of reasons. And then number 2, if there's water there now, presumably there was water there in the past, and if there's a volcano there now and also in the past, that is heat. So maybe lifey life stuff.
Oh,
yeah.
Okay.
You can dig a mow hole. That's what you do in terraforming Mars.
Energy and water.
Yeah. So that's really exciting.
Fun. Well, our trivia today is inspired a little bit by the SpaceX Starship Super Heavy whole architecture thing, because, as you mentioned, Addie, they have to do a refueling for Artemis 3. They have to launch a Starship, then they have to launch another Starship with fuel and dock these 2 big rockets in orbit and transfer fuel between them.
I was talking with somebody recently about how like they hadn't realized that like the plus 17 or 10 or whatever it is, like launches that are required, but they were looking at like the Artemis swoosh chart. So they just these like charts that show all the different parts of the mission stages and everything. And they were like, what are those tiny little rockets down in the corner of the diagram? Continue.
So docking is a key part for the whole Artemis return to the moon. Not only do the Starship have to dock and do some refueling, the Orion capsule, where it's just carried up by the NASA SLS, has to get to the moon, dock with the Lunar Gateway. Starship has to dock with the Lunar Gateway, go down to the moon, come back, dock with the Lunar Gateway. There's a lot of docking going on. So the
much
trivia
docking.
is, when was the first docking of 2 spacecraft in orbit? And
crew or uncrew?
When was the first one?
Okay.
And were there people on board either of the 2 vehicles? Okay. So that's your trivia we're going to come back to. But first, we're going to take a journey out a little bit further in our Walkabout the Galaxy.
So distracted now.
The constellation Corona Borealis.
Ooh.
Which is home to a star called T CRB T Corona Borealis.
T-Crib. That's my rap name. T-Crib.
T-Crib.
It has the nickname the Blaze Star.
Oh, that's
my rap
much better rap name.
Star. So this
has different implications than this one, I think.
This star it's actually a binary star system, as many star systems are.
Yep.
And it consists of a red giant and a white dwarf.
Oh, you know what that's going to mean?
Nova. So these two stars are orbiting each other. One of them has truly finished all of its sort of nuclear reaction phase, and what's left is a white dwarf that's the sort of the core ember of heavier elements, carbon, nitrogen, oxygen, and the core of what once was a star like the sun. So it sort of has no more fuel, but it's as massive as a star, but it's like the size of the Earth.
Yeah.
Orbiting it is a giant red star, giant red giant.
Yep.
Which is
large,
very
giant,
bloated.
Yeah,
is the word I'm looking for.
Yeah.
So
it's a lot of
material,
a lot of gas, a lot of bloating happening.
Gas, very bloated, and it's, as one does, loses some of that gas when one is bloated.
Sure.
And so it loses that gas to the white dwarf.
Yep.
Which lands on the white dwarf, and it builds up and accretes, and because there's this intense gravitational pull, the weight of that gas is very, very heavy on the surface of the white dwarf.
You know what happens? Keep piling it up.
Stuff, you're piling up hydrogen from the outside of one star onto what once was the core of another star. It gets hot enough to go through basically runaway nuclear fusion again.
About 1.4 solar masses? Is that?
No, it's not that kind.
That's the other kind.
The supernova kind.
Oh, that is supernova kind? Okay. Oh, that's right. Novas can happen earlier than
So this is basically like giant hydrogen bombs going off in the surface. It's like inside a star, you have these hydrogen fusion going on in the core, but it's moderated by all of the weight of all the stuff around it, so that energy trickles out in this nice controlled flow, which gives us the shining of our star.
The shining.
But there's no outer buffer, so you pile up enough of that stuff, and it goes through a runaway nuclear reaction on the surface, and you get a very, very fast, very, very rapid, sudden increase in radiation from that thing. It's called a nova. Or
you should teach astronomy 101.
Once upon a time. And so this particular one is unusual because it does it kind of periodically.
We love a periodic star.
One of only a few stars called a recurrent nova.
Oh.
And, presently, it's way too faint to be seen with the unaided eye, about a magnitude of 10 or so, and that's mostly the brightness of the red giant star. But in 1946, it reached a magnitude of 3.
Whoa.
Which is hundreds of times brighter, more than hundreds of times brighter. And in 1866, it reached magnitude 2, which is another couple of times brighter than the magnitude 3. And so, I guess the magnitude 3, not hundreds. It's over 100, but not 1,000 times.
Magnitudes, logarithmic.
Brighter. There's 5 magnitudes is a factor of 100, I think. So in any event, that's bright enough to see with the unaided eye if you're not in a city, for example. So if you're in a reasonably dark sky environment, you could just see this star where there is no star currently. It's in the constellation Corona Borealis, as I said, that's visible in the northern hemisphere. Pretty far northern constellation, sort of at the same part of the sky as the Big Dipper, but kind of around a bit. But sort of that distance from the North Star. So for our listeners in the northern hemisphere, you may notice that 1866 to 1946 is 80 years, and the next 80 years would be 2026, which we're not quite at. However, there's observations of it in 1945 showed a dramatic change in brightness of the red
before
giant before it happened, fainter that we have just seen.
Oh,
interesting.
So their speculation is that the blaze star may be queued up and ready to blow.
Exciting.
This year in 2024, sometime in the next 6 months or so.
Wouldn't it be so crazy if it was happening also during when the solar eclipse was happening, and we have all sorts of crazy astronomical events going on at the same time?
That would be so cool.
And maybe a human-eating plant, singing plant might
Exactly.
happen.
Exactly.
So it will be bright for days, not weeks. Not even a week.
Oh, wow.
But
Days is good.
days is enough so that you don't have to be like so lucky that you happen to be looking up. when
Right.
it happens,
That's what I was thinking.
So somebody will see it, and then you get
Probably a bunch of people are going to train their telescopes on it, too.
Yes. Yeah, it would be very cool to be seeing that happen. So if you're an amateur astronomer and do that kind of thing.
Yeah, or professional astronomers looking at some data, too.
Yeah. So we will post about that when it blows, because it probably will, if not in the next few months, at least in the next year or two. So that's pretty cool.
That is really cool.
The chance to see a nova.
Yeah.
Different from a supernova, which is what you're referring to, the 1.4 solar mass limit for a white dwarf, when it accretes so much stuff that the whole thing implodes and then explodes.
Right. That's what I'm more familiar with. Wait, why does the red giant decrease in luminosity beforehand?
I don't know.
That doesn't make sense.
I mean, it probably does make sense.
It's like feeding the other one, but like a drastic decrease.
So
I don't know. It's fine.
I don't know. So there's the honest and short answer.
We'll look it up.
In June 2018, the star had dimmed slightly. In March or April of 2023, it had dimmed significantly by a couple of magnitudes. A similar dimming occurred in the year before the 1945 outburst.
It's happening.
6 outburst, actually. So I don't know. I mean, maybe it'll happen in the next 6 months. Maybe it'll be 18 months.
Okay.
Yep. Stay tuned.
Stay tuned.
Okay. First docking.
Oh, yeah.
When did that happen?
I don't know. 1965.
It's not a bad guess.
It's not a bad guess, perhaps. Perhaps not. Perhaps it's a terrible guess.
Perhaps.
My brain is totally failing me. 1963.
Audrey gets this one.
Yeah.
Do I?
Yeah.
March 16th, 1966. It was with people or
It was
not
with people.
With people.
on one or both.
One.
You're both correct.
Yeah.
It was, in fact, the Gemini
It was
8
Gemini.
mission.
Yep.
And
I wouldn't have known the name.
the final follow-on is who was the commander of Gemini 8? Multiple choice.
Oh, okay.
Neil Armstrong, John Young, Jim Lovell, Scott Carpenter, or John Glenn?
John Young.
John Young?
Neil Armstrong.
Oh, it was Neil.
It was Neil Armstrong's first flight
fun.
in space.
Oh.
And
I didn't think that was.
yeah.
Okay.
So there was
fun.
He and David Scott, and this is the one where there's a very dramatic sequence in the movie First Man depicting this. So they launched a robotic spacecraft called the Agena.
Yep.
And then the Gemini 8, which is a little two-person capsule,
Little tiny
goes
capsule.
up to catch up to it in docking, which you have to think in 1960s technology. I'm still gobsmacked.
It's like
that they can do
physical
this.
switches to change bits.
I'm just like flying around, orbiting it's complicated business. It's not like docking airplanes or ships or anything. It's very complicated. So they managed to dock, and then they noticed that the thing they docked to was supposed to do some maneuvering. They had all sorts of fancy things planned. There was going to be a spacewalk with a very long tether and doing all sorts of cool stuff. But it started rotating. They're like, that's not supposed to happen. So they stopped it, and they thought the other thing is making us roll.
No,
it turned
they were
out
venting.
It was they who were making them roll. So they're like, we got a problem. We need to undock. As soon as they undock, they no longer have this giant multi-ton thing attached to them. So then they start spinning crazy fast. And yeah, and it's depicted as a pretty dramatic emergency in First Man, and it turns out it was a pretty dramatic emergency. They
In real life.
it was a life-threatening mishap.
Yeah, generally spinning really fast is not a great situation.
Not a great thing, and they were burning up fuel like nuts.
Yeah.
And Armstrong switched over to a different different rocket system on board for reaction control thrusters to stop them tumbling, and saved the day. God. Yeah, pretty exciting.
Yeah.
Who would want to be an astronaut?
I would want to, I think.
Oh, I'm raising my hand. Sorry, listeners.
While it may have felt like a year in Vallis Marineris, it was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the universe.
Be sure to follow us on Facebook and Instagram to get all our updates, subscribe to our YouTube channel, and catch up on old episodes wherever you get your podcasts.
Our theme music was composed by Richard Jarusik. Production assistance is provided by Logan Basinger.
Thanks to our listeners in Vermont and around the world. Stay safe. I'm Josh Paulo.
I'm Addie Dove.
And I'm Audrey Martin.
We're the Astrocork, signing off until the next episode of Walkabout the Galaxy.
Voyager 1!
Uh-oh.